Hello. All right. Let's do some long division. Okay. I had posted, I thought, a couple videos from Miss Holmberg, but now I see that maybe they're not on there. Either way, we're going to do long division the way we have learned it in class, which is called explicit trade, but it is very similar to the way your parents learn long division. So I'm going to make up a number. I'm going to say 723 divided by 8. Okay, so this 723 is the number that we're going to be dividing. It's called the dividend. It is the number that is in the den. It's like a bear in a cave. It's kind of tucked in here. This 8 is how many groups we're going to be splitting the number into. So if you think about money, there's 8 people. We're going to share this money with 8 people. That is the divisor. And then this number up here that we're going to be putting is the quotient. That's the answer. That's going to be how much money each of these 8 people get once we split it up. All right, so what I always do is I'm going to split up, just going to kind of draw some columns through my place values so that I have a hundreds, a tens, and a ones column. Okay, first up, I've got 7 hundreds. So think of it like I have $700 bills. And I've got 8 people that I'm going to split this with. So do I have enough $100 bills to give one to all 8 people? I don't. So what I need to do is I need to take these $700 bills and take them to the bank. And I'm going to cash them in for 70 $10 bills. And you guys know that 700s is the same as 70 tens. So 700s is the same as 70 times 10, right? We did that on place value. So I'm going to take this 7, and really what I'm going to do to make it 70 tens, I'm just going to shift it over one column. I already had 2 tens, and then I traded in my 700, so now I have 72 tens. All right. If I look at my multiplication chart, I know that I can split up 72 and split it with 8 people, and each person gets 9. They get 9 tens because 9 times 8 is 72. So here's what I just did. This is the number of tens I had. I could give all 8 of my friends 9 $10 bills. I could give them all 9. And 9 times 8 is 72. So I put this 72 here because that represents how many I gave away. So do I have any left over? I started with 72. I gave away 72. So I don't have any left over. Now, if I did, I would need to cash those in for ones. I would need to trade them, but I don't. So now I have 3 ones. I cannot give 3 ones to 8 people. So I'm going to give 0 ones. And it's important that you put that there because a 9 and a 90 are 2 different answers. So I can't give everyone a $1 bill. And if I can't give it to everyone, then I'm just going to have to give them 0. 0 times 8 is 0. This represents how many I gave away, put in each group. So how much do I have left over for me, I guess? Well, I have a remainder of 3, which is this number right here. So I gave each of my 8 friends $90. And in doing that, I gave away all this money except for $3. And that's my remainder. Okay, let's do another one. And what would be great is if you think you're getting the hang of it, you might want to go ahead and pause it once I show you the problem. I'm actually making sure we have one that doesn't have a remainder this time. Let's do, okay, we're going to do 1,300 divided by 4. Okay, you see how I space these out? That's really important because when we shift things over to the next place value, when we cash them in, if you don't leave a lot of space, your numbers are going to get really jumbled up and it's going to be hard to keep everything straight. So let's go ahead. We're going to have a thousands place, a hundreds place, a tens place, and a ones place. We're going to dive in. I have $1,000 bill. Can I give each of my 4 friends a $1,000 bill? No. So I could put 0 here if I wanted to. 0 times 4. I gave 0 away. So I still have $1,000 bill left. So I'm going to take my $1,000 bill and cash it in for 10 $100 bills, which makes this 13 because I already started with 3. So I shifted my 1 over, and now I'm going to see how many $100 bills I can give each of my friends. Well, I know that 3 times 4 is 12. So I can give each of my friends $300 bills. 3 times 4 is 12. And so this 12 represents how many I gave away. All right. So now, once I find the difference in how many I had and how many I gave away, I have $100 bill left. So I'm going to need to cash that in for 10 tens. So I'm going to shift it over. So now I have 10 $10 bills. I'm going to share them with my 4 friends. So I can give each one of them 2. And in doing that, I'll have used 8 of my $10 bills. So I have 2 left over. Let's shift this over, trade it in for 21s. And if I have 21s, 4 people, they each can get 5 $1 bills. And I'll have used all of my money up. So my quotient is 325. Now I can check to make sure I'm correct because the opposite of dividing, the inverse operation of division, is multiplication. So if I come down here and multiply this, now I'm going to do standard algorithm because that's just the way I do it. I know I'm right because 325 times 4 equals 1,300. All right, we're going to do one more, and it's going to be a doozy. So hold on to your horses. We're going to tackle one of these 2-digit divisors. Okay. We are going to do, and don't faint on me, 7,807 divided by 37. You're thinking, I know what you're thinking. You're thinking, Sanders, you are nuts. I can't do that. Yes, you can. And I'm going to show you how. If you can do the last 2 problems, or if you're starting to feel comfortable, guess what? The only reason this is scary at all is because we don't know fast facts for 37. But we can fix that by making our own multiplication chart for 37. So I've done a little front loading work here, and I've already figured out all the multiplication chart, all the multiples for 37. So I'm going to write these down. Let's see if I can scoot this up. Whoa, my ladybug's moving. Okay. Okay, so I'm basically just making a row for 37 on your multiplication chart. I'm going to write it out here. Now, how do I do that? Well, 1 times 37 is 37. Then I'm just going to add 37 to that, which is going to be 74. Then I'll add 37 to that one. It's going to be 111, and so on and so forth. Is this going to take a long time? Yes, it is. But it is well worth your time because once you do this, you're going to see that the process is no harder than the ones we did on the last 2 problems because you have all of these facts just right here at your disposal. So even if you have to take your shoes and socks off and count your fingers and toes to make this happen, and it takes you 15 minutes, It is worth it because I'm going to give you the whole class period on a test to do this, and you're only going to have one, maybe two of these type of problems. So you're going to have plenty of time. So do your best, figure out your facts over here, and now we're ready to tackle this. So we're starting with 7,807. We're splitting it up into 37 groups. We're giving it to 37 different people. Okay. I've got 7. Can I split that with 37 people? No. I'm shifting it over. Okay. Now I have 78. Can I split that with 37 people? The answer is yes. But the next question is, how many $100 bills, because we're in the hundreds column, how many of these can I give each of my friends? Well, I'm going to come over here to my chart, and I got to see how close I can get to 78 without going over. So I don't have 111 hundreds to give, but I do have 74. So if I give each of my people 2 from this column, 2 times 37 is 74. So I had 78. I used up 74. I have 4 left over. Okay, now I'm going to trade these out for 40 tens. So we're going to do the same thing. I don't have 74. I do have enough to give everyone 1, because if I give everyone 1, I'll have used 37. So 1 times 37 is that. I've got 3 left over. So now I've got to take my 3 and shift it over a place value, turn it into 30 ones. So now I have 37 ones total. How many can I give my 37 people? Well, I can give them each 1. So 1 times 37 is 37. So I hope you see that this is exactly the same process. It is not any more complicated. I'll tell you the only thing that's more complicated. There's 2 parts. Making this multiplication chart, which is adding. You're very good at adding. And sometimes the subtraction gets a little hairy because you're dealing with bigger numbers. But that's nothing we can't handle. This type of problem is going to take the longest amount of time of anything that we do all year in 5th grade. So if you can be patient and you can take your time and be precise, if you can spread out your numbers and write cleanly, then you are going to do fantastic. So if you have questions after you've gone over this, please email me or come to one of my meets. We can totally knock this out one-on-one in intervention. So I hope you have a fantastic day. Thank you for playing. See you later.